So this is part B of the banana oil lab. We'll be vacuum distilling. Could you hold up the liquid, please? Yeah, there you go. This liquid, which is pretty ugly right now, it's just a brownish or reddish liquid, and it's going to actually become nice and colorless at the end. And we will be setting this up as a vacuum distillation. So let's go ahead now, Jenny, and set this vacuum distillation up. She's got all the bits and pieces in front of her. She's now going to go ahead and grease the joint, and she's just using a line of grease around the joint there. And the most efficient way to put this on is just to go ahead and plug it on exactly like that and not to twist it. So don't twist it. Now I'm going to zoom in here so that you can see how Jenny puts on this keck clip. These keck clips are going to be absolutely necessary to put around these joints so that it holds together. Otherwise you're having it held on by fate alone. I'm going to have you do that again, please, Jenny. So what she's got, do you mind if I... Okay, so this has two parts to it. You see it's got a big part and a little part to it. Now on the joint, let's take a look at the joint here. Do you mind putting the joint in the... There we go. We've got a big part and a little part. So the big part goes around the big part of the joint and the little part goes around the little part. Would you please go ahead and stick that on? Oh, okay, sorry, you could use that one. There we go. So now it's on there. Could you please just gently pull, and you can see that it doesn't come apart. So that's very nice, isn't it? All right. Let's go ahead and put the rest of it together, please. And you'll notice she's diligently greasing those joints. Oh no, that doesn't go there. That's where the flask will go, Jenny. This is the thermometer adapter that she's got now. Could you bring the thermometer adapter a little bit closer, please? It actually consists of two parts. That part and then this rubber part here. Thank you, that's great. Now she puts the rubber part on top. Would you show the camera doing that, please? There we go. And then show the result. Now a little bit lower, please. There we go. And you can see now that rubber part's on top. That's great. Okay, now let's go ahead. That goes in the top of that Bison adapter. There we go, perfect. That doesn't need a clip because that's going to be held in by gravity. Okay. The thermometer goes in there. Would you mind putting the thermometer in, please?
I'm sorry, I'm going to try to identify you.
Now the bulb of the thermometer will go down to about where the neck comes out. So it needs to go down a little bit further, a little bit further. There we go, a little bit further. Alright, that's about perfect. So could you please bring that a little bit closer to the camera? And you can see where the bulb of the thermometer is supposed to go. That's excellent, thank you. Alright, so let's go ahead and put why don't we put the flask in next? Oh, actually, no. Let's fill it. Let's put that down for now, please, Jan, and we will we'll put the liquid into the flask. But we're going to use the small flask there. Yeah, I'd recommend using this. I'm going to put it on there. You can put it back in the thing, please. There we go. It's a 25 ml round bottom flask, and now she's going to go ahead and pour her liquid in there. I've also got some boiling stones in front. She'll put them in a second. Now when she pours this in, it's going to have a little bit of magnesium sulfate. Would you put it down a little bit, please? It has a little bit of magnesium sulfate on the bottom of it. She's going to be mindful of that, and she's just going to decant, which means she's just going to pour it in while trying to keep the magnesium sulfate in the bottom of that flask or in the side of the flask. If you get any in the round bottom flask, it's not any real need to panic because it won't distill over, but we're going to try and avoid it. Would you mind bringing that closer to the camera? And you can see she's left the magnesium sulfate in there. That's perfect, thank you. Now we've got some boiling stones there, and we're going to stick those in as well. All right, that's great. Okay, now what I want you to do is put that flask into the clamp And we always do this by the neck of the flask. Okay, that's good. That's good. All right. Okay, that's nice. Now what I want you to do, please, Jen, is put the setup that you just made with the thermometer, that goes in the top. All right, that's great. So if you look at the setup here, we've got the thermometer in the thermometer adapter in the Kleisen adapter, and the Kleisen adapter is attached into the flask. Now what Jen's going to do is attach the condenser. Actually, before we put the condenser on, why don't we put the tubing on? I think that's a smart play. So just for now, go ahead and put the two tubes, attach the two tubes to the condenser, and we'll decide later which tube will attach to the faucet and which one will sit in the sink. But it's always better to attach the tubing before you set it up. Otherwise, it becomes a bit of a mess. Alright, so yeah, we will worry about the tubing in a second. So let's go ahead and plonk that onto the Kleisen adapter. And again, Jen is going to use a clip, a Keck clip. And remember, the big part goes around the big part, little part goes around the little part. That's perfect. Alright, that's good. I know it looks unstable, but it's okay. That's good. Alright, let's go ahead and put the receiving flask on the end, and we'll clip that on as well.
Unless when you cook up the
Alright, so now we've got 3 clips there, and you can see how careful she was in making sure that she never set this up so that something was being held on without a clip. Because sometimes that's what people will do, is they'll stick something on with grease thinking it's going to hold, and then of course it falls off. That's why it's really important to make sure everything's clipped here. Alright, let's go ahead and lower that into the mantle. But would you raise the mantle a bit, please, first? This will enable us to remove the mantle if anything happens here. So that'll be fine, Jen, as far as the height goes. Let's lower the flask into the mantle, please. It's really, really important here to make sure that the flask will be touching the side of the mantle once it goes in. So if you have to move the mantle around so that it's touching the side of the flask, then that's what you'll have to do. I'll actually show that on the camera in a second. Let's move this setup so it's touching the side. Alright, there we go. Now you can see how that's set up. If it's not touching the side, it won't heat properly. That's good. This mantle is not on yet. That's important as well. Alright, as far as the tubing setup goes, the bottom tube, the one that's attached to the bottom of the condenser, is the one that goes into the faucet. This will have the effect of filling the faucet. There we go. No, the faucet. There we go. Right, and the other one will go into the sink. This will have the effect of filling the condenser, which is what we want to do here. The other thing is that we are going to have to attach the vacuum pump, and I think we're in the wrong place. So we're actually going to move this and put it into a location where it can be attached to the vacuum pump. We're going to see how we read the pressure on the vacuum pump. So there's the vacuum pump in the background there. Could you point to it, please? Thank you. And what I'd like you to do is turn it on, please, Cassidy. Oh, let's make sure it's plugged in. It usually helps. Alright, there we go. Let's plug it in and turn it on. And now what she's going to do, I'm going to zoom in here. She's actually going to attach, there we go, thank you. Attach the back of the pressure gauge to the pump. Make sure you've got a good seal around that, please, Cassidy. force it on there a bit.
It's in your lap.
Did you eat your Wheaties this morning?
Yes, I did.
Okay, that's good, perfect. All right, let's take a look at the gauge. I'm actually going to zoom in on the gauge here so you can see how we read it. And you see this one is 0 down to -30, so this is actually showing true vacuum here. This would not have to be subtracted from 760. So now Jen is going to plug in the vacuum setup into the nub there, or the little nipple part that's on the end of the collection adapter. There we go. Now we've got this set up so that it's close to the vacuum pump for one thing, but also so that the liquid, the water, can flow through the tubing and into the sink as well. So now she's going to go ahead and turn on that water, and she's going to do so fairly slowly. We're not interested in a huge water flow here, just enough to keep the water flowing. Yeah, it's probably sufficient. Would you please hold up the other end here and we'll... Yeah, you can see we've got some stuff flowing out the end. That's good. That'll be fine. Thank you. All right. So we've also already calculated what boiling point we're expecting to see here. So we'll have an idea about that as well. But we will see whether or not we actually reach that boiling point. I'll show in the other part of the video how we get that calculation. All right, now that we've got everything set up, we can go ahead and turn it on, making sure, of course, that that flask is touching the side there, which is good. Could you please turn the thermometer around, Jen, so that we can get a better view of that? There we go. Turn the adapter. There we go. That's better. All right. So now we can see the measurements on the thermometer, and now we can go ahead and now you're going to put that in ice too. There we go. So the collection vessel needs to be in the ice, and that should, yeah, there we go. All right, that's perfect. All right, now we can go ahead and turn it on. Alright, so as I said, we'll sort out the boiling point calculation in a bit, and for now we're just going to see where this will end up coming over. Now, is the vacuum, turn the vacuum on, there we go. And what's going to happen is that this will begin to boil relatively quickly because it is under vacuum pressure. In fact, you can already see bubbles forming in the solution, which is great. We've got our temperature here that we can read off the thermometer, and what we're waiting for is a constant temperature, constant boiling temperature, and that will show us our observed boiling point for the liquid as it comes over. And that should be fairly constant as we're doing this. We're going to do this until there's a little bit of liquid left in the bottom of the flask, and I will film that towards the end. Temperature setting of 5 on the mantle should be sufficient. So it's boiling now, as you can see, but there's nothing coming over yet. The temperature right now is about 25 degrees. So we're going to wait until that temperature starts to go up and we start to see material coming over through the condenser and into the collecting flask. And I'll show all that once that starts to happen. So as this is boiling, one trick we can use to see where it might be is we can just gently touch here and see where it's warm. And you can see here, it's warm there. It's not quite warm here yet, so it needs to come up here a bit more before it hits here. You've got to be very careful with that though. You don't want to burn your finger obviously, but you can get an idea of where the vapor is coming up through the system. So now it's boiling and the temperature here is going up on the thermometer. I'm going to see if I can zoom in on the thermometer here, and you can see it's around 50 but still climbing. There's no liquid coming over here yet, and the reason is because the vapor, well, it's just hitting the thermometer right now. You can actually see a little bit of a drop of material here coming down off that thermometer. So now it is going to start coming over pretty soon and it's coming down the condenser. Do you see some there, Cassidy?
Yeah, right at the end here. Just little drops.
Okay, so we are seeing some drops now coming into the receiving flask. That's good. Yep, I can see them there now. So what we're doing is we're going to wait for this to pretty much stabilize, and it looks like it has. It looks like it's stabilized at about, let's see if I can get this to focus here. It's stabilized here at about 50 degrees, and that's the constant temperature, say about 52. That's the constant temperature that we're going to put down here. And you wait for it to be coming over before you measure that and make sure it's stopped going up. So for now what we're going to do is we're going to wait for this to finish distilling, and we're going to leave it so that there's a little bit of liquid left in the bottom of the flask here. So what we're seeing here is the amount of liquid in the bottom is decreasing quite a lot. With that, the boiling action might become a little bit more vigorous as the solution thickens up a little bit as well. But we're going to keep this going until there's a little bit less than what we have now in here. But we don't want to ever let this run dry. So now we have just a fairly small amount of liquid left in the bottom of that flask now. So we're going to go ahead and turn that off. Now if you look in here, you can still see the nice clear liquid here compared to the horrible brown liquid that we have left in the distilling flask. Alright Jen, I want you to go ahead and turn off the heat and take the heat right away from the flask. And you can see what she's doing there is taking it right away, and now she's going to remove that from the flask. That's perfect. The next thing I want you to do, Bonnie, would you please, or somebody, Iris, would you turn off the vacuum, please? Okay, that's great. Now, Cassidy, would you please remove the tube from the collection adapter? Now, you'll probably, just sort of might have felt a little bit of vacuum there, and that's okay. And now what we can do is, I'd like a small beaker. That's for the weighing. Can I have another small beaker, please? Yeah, that's perfect. Would you please remove the round bottom flask from the bottom there? And replace it. I'd like you to replace it with the beaker. So just in case there's still some liquid coming down, so that can drip into that beaker. That's great. Okay. So she's just going to remove the flask there. Okay, that's good. And there we go. That's perfect. And you can see what she's done. She's taken the flask off. And then we're wiping it off here as well. And she's going to put it into that cork ring. There we go. And we have a small beaker over here. Would you hold up a small beaker, please? That small beaker has been weighed. And what Cassie is going to do is she's going to pour the liquid into that small beaker, and then she's going to weigh it. And that will be the yield of our pure product. In the meantime, we can go ahead and turn off the water here as well. Would you please do that? Thanks, Iris. And then we can begin to take this apart once it cools down. Now, because we didn't do this to dryness, this will be fairly easy to clean. We'll be able to pour that liquid into the waste container and then rinse out the flask with water, and everything should be good. If we'd let it run dry, it might have been very difficult to clean because it would have gotten baked on. What we've got here is a pressure temperature nomograph, and what this allows us to do is to calculate a boiling temperature at reduced pressure. Now on the page you see this is where the pressure is, We actually got a pressure. What was the pressure?
21.
Yeah, it was 21 millimeters of mercury. So that would be about here. Would you mind putting a cross in there? About 21. So it'll actually be a little bit on the other side. That's 10, then the other one's, yeah, it's on the other side. There we go, perfect. Right. This one here is the boiling point at 760 millimeters of mercury. That's the atmospheric boiling point. We're actually given that in the lab up here. It's 143. Would you please mark down the 143 on there? All right, so what we're going to do, or what Cassie's going to do, she's going to run a line through the 21 millimeters of mercury, through the actual proper boiling point, and it's going to go down onto the line that's on the far left. So go ahead and let's go ahead and run the line through there. Okay, perfect. So where that line intersects here, that is going to be our boiling point that we should get. And this one, looking at the degrees Celsius here, it looks like it comes out to be around about 50. Yeah, around about 50 degrees. So that should be the expected boiling point. If we look at the boiling point we've got here, we get a bit more than 50. We expect that because the seal in the vacuum setup is not going to be very good because there's going to be lots of leaks. So we expect a slightly higher boiling point that we observe in our setup, as we've got it over here. Yeah, a lot of potential for leaks here in the vacuum, which means that we see a higher temperature observed here than what we calculate off the nomograph.